Right, good morning. I'm going to start on time, which obviously has no bearing on whether or not I finish on time. But I will try. I am also keenly aware that we're going to head into lunch. Actually, I'm going to make you slightly hungry partway through. Yeah. Hungry for knowledge, that's what we're here for. Right, okay, so my name's Kevlin Henney. I want to talk to you about technical neglect. You already know what technical neglect is, but you just haven't had a name for it. And naming things is surprisingly important when it comes to communication and being able to reason about the challenges in our codebases, the difficulties that we have in architectures that have been around for more than maybe 5 minutes, and our ability to deal with that or not deal with that. That appears to be the problem. And part of our problem is that we misidentify the issue. The major, and the reason that is because we have, the stuff we deal with it's not even slippery. Software is not slippery because you can't even hold it. It's quite insubstantial. It's, the way that I describe it is it's not kickable. And kickability is clearly a property that you often want with the code, but you're frustrated. So the fact that it's not kickable, not physical, is actually kind of a bit of a challenge for us humans who have been fine-tuned to the real world, which is primarily physical. And so therefore we will look to ways of describing abstract and virtual concepts. So neglect is something I'm going to look at here. So my name's Kevlin Henney. I'm an independent consultant, trainer, and things. I used to just put my Twitter handle up there, but these days in the fragmentation we've experienced in social media, I've just given up. Here's a shopping list. You can find me anywhere. And if we don't have time for questions, obviously you can come up and talk to me afterwards, but also feel free to communicate with me on any of these channels. Although I'm probably less responsive to technical discussions on Instagram. So here's the thing. Cause and effect. The nature of causality is that we have a concept of the times arrow, which runs from here to here. We normally experience an awful lot of this and spend a lot of our time trying to figure out this. But it also means that sometimes we confuse things. We sometimes misattribute something as a cause when it is actually an effect. And the one that I want to talk about here is technical debt. Just quick check, who uses this in their conversations at work? Yeah, I'm going to teach you what it means. Okay? We often attribute technical debt. We often say, oh, that's the problem. Actually, it's an effect. The thing we need to be looking at is the cause. Now, this is not the sole cause of it, because it turns out technical debt is not a bad thing. It's not intrinsically a bad thing, but people normally use it that way. So we need to understand a bit more about technical debt. Specifically, what we're interested in is the kind of technical debt that falls outside our ability to manage it, and is a constant state of surprise, but also a constant state of frustration. It frustrates our efforts. And we'll look at some numbers to see to what degree it does frustrate our efforts. And the notion here is that neglect is the cause of a lot of this unmanaged technical debt. Now, why is this such a difficult, why is it such a difficult thing to identify and see? Why is it that we haven't used the right metaphor, the right terms for this? Well, quite simply, neglect is a thing that doesn't happen. Okay? We are very good at spotting things that happen. Oh, there's a thing that happened. There's another thing that happened. Okay? We can see things that happen. We're very good at that, and we look for them. It's very difficult to notice the absence of something. And that is very much the definition of neglect, whether it's physical neglect, emotional neglect, urban neglect, whatever it is, it's a thing that didn't happen. It's not a thing that happened. You're looking for something that's not there. That's why it's so subtle. So, honestly, I can't remember where I took this, obviously near a large body of water. But there's a boat. It looks kind of abandoned. I'm just going to say that it's got a hole in it. and we take it out onto the water, because we're software developers. We take it out onto the water, not realizing it's hardware problems. We take it out onto the water, and that whole, well, there's water coming in now. The boat's going to sink. We're going to solve this in two different ways. We are going to solve it, first of all, as software developers, and then we're going to solve it as the rest of humanity. You're a software developer, and it's kind of like, you know what I need to get really good at? I need to get good at emptying the boat. That's what I need to do. There is an effect here. It's got, right, let's work on that, getting the water out. Let's squash those bugs. Let's do all that kind of stuff. Everybody else is going, you know what? We don't just want to get the water out, but maybe we should stop the water coming in. Mind blown. And this actually was one of those things that came to me a number of years ago. A couple of clients, I ran workshops on what to do with their legacy code. And, you know, I'd say those were fairly successful. We worked out what to do with it. We worked out how to empty. In fact, that was their focus. I was kind of assuming that they would extrapolate. That is a mistake I've made so often in my career that, you know, I'm just excited for the opportunities for me to make that mistake in the next decade. What extrapolation am I going to make that turns out not to be true? I am going to give you an extrapolation that I made that does turn out to be true. But there is this notion, I kind of assumed people, I thought it was implicit, but it turns out that a lot of things that are implicit, particularly in a software development environment where we're dealing with so much complexity, there are so many things happening, you can't focus on everything, because by definition, it's not focus if you're focusing on everything. You will let things slip. So yes, you do need the obvious stated. It's of value to all of us. But that's the thing I noticed, is these people did actually manage, particularly in one case, they managed to do a really good job of dealing with the water in the boat. They managed to deal with, have a plan for their legacy. The problem is they kept producing legacy. It was a steady state problem. You have to ask yourself the question, how do we not do this again? What is it that we need to change? What causal thing do we need to change to avoid the effect, rather than fixing the effect, rather than addressing the symptoms? Now, I am being very unkind on software developers, but I feel that that's appropriate because, we're here. And software developers are inherently optimistic people. I mean, pause for a moment and think about it. You wouldn't do it if you didn't have some deep-seated sense of optimism. But let's start looking at how to reframe our thinking on this. And I'm going to go back a few years. This is Maya Lehman, who published this paper in 1980, which is quite a long time ago. And it's kind of interesting because, if we think from now to 1980, that's 44 years. If you go back from 1980, 44 years, that kind of puts you back in a time when wars didn't even have numbers. That's the kind of relative distance. And still, he was making an observation that we find incredibly true, still true now. As an evolving program is continually changed, its complexity, reflecting deteriorating structure, increases unless work is done to maintain or reduce it. Now, there's a number of points here. First of all, brilliant observation. He was actually making these observations in the 1970s. The paper, by the way, just so that we've got, in case you can't see it, programs, life cycles, and laws of software evolution. Really interesting read. And a lot of ideas, nearly half a century later, you go, oh, okay, this is quite an old idea, but also there's different ways of thinking things. I found this paper to be filled with good ideas that we've somehow overlooked. But he's making a couple of observations here. One is the very nature of applying change to a system will degrade its structural quality. Even, and this is kind of implicit, so let's make it explicit, even if you do a good job. Of course, if you do a bad job, it's going to degrade faster. So it's not one of those cases of like, oh, there's no point in trying because it's always going to get worse. No, the rate of decline. If you're applying all your best practices, that's certainly going to be a massive improvement on not. But what I'm saying here is that if you are applying all your best practices, you will still experience typically a degradation of quality. It goes back to the idea of focus. The idea of focus is you're so busy focusing on this thing, whether this thing is this method, Whether this thing is to introduce this dependency in a way that you find clean and satisfying and comprehensible. And you put tests around it and you do all the right things. Surely there's no degradation of structure there, or no opportunity for degradation of structure. Actually, there is, because perhaps what you've looked at or not looked at is the larger context, because you've been focused. Remember, this is the nature of attention. The idea of attention is that focus is where you put your attention. By definition, that means you're taking it away from everything else. You are ignoring everything else. You cannot focus on everything simultaneously. So you probably ignore the context. You probably ignore the fact that maybe this dependency, introducing this, has a conflict or makes some other dependency redundant. Okay, that's fine. We expect that. Maybe you'll notice this in 5 minutes. Maybe you'll notice it in 5 weeks. Maybe a colleague of yours will stumble across it in 5 months. The point there is, even when you're doing the right thing, there is still an opportunity for this degradation of structure. In fact, we might actually say that this is inherent in physical processes. When we do something, there is a side effect, and we understand that. I don't tend to if I go to the kitchen to make a meal, I do not declare, right, I'm going to the kitchen to make a mess. There will be a mess. I like to think that the mess I create is kind of contained, and I tidy as I go, more on that later. But there will still be a mess. I still have to account for the fact that I will need space for dirty dishes, that I will need to do the dishes, even if it's to put it in, as we refer to it at home, the dirty dishes cupboard. I will have to do something there. The very process of creating a meal, consuming the meal, will involve making something dirty. It will involve making a mess. I'm fine with that, because that's the way the physical world works. If you've had any work done on your house, you'll know it gets messy before it gets better. And it's inherent. We assume that as normal. We don't do that in software. We assume that the work we've just done is the work in its totality. We don't allow that little buffer of, you've got to tidy up. You've got to account for, let's give it a term, cost of ownership. Yeah? Apparently businesses think they can do software for free. I think this is beautiful and sweet and tragically economically dumb. You can't have code bases and you can't work on code bases for free. If you put in your requirements, you also have to deal with the consequences of creating and working with software. There is this idea that you have to maintain it. Let's go back to the dirty dishes cupboard, our dishwasher, and in fact other items we might have in the kitchen, and adjacent utility spaces, a washing machine. It needs to be maintained every now and then. Even our oven needs to be maintained. Now, maintenance, he uses the word maintain. Maintenance is a thing that happens is a requirement for physical things, because through our interaction with them, we have wear and tear. That's just the way that it works. Now, of course, I'm not saying that your code needs maintenance in the runtime. I'm not saying that, we've left this binary for a year, all the ones have decayed into zeros. It's not like that. Or, has anybody touched this source code, since last year? No. Yeah, I've noticed the curly brackets are kind of beginning to fade or fall off to the bottom of the file. That's not what I mean. It's the idea that the interaction that we have with the code to do anything is likely to have these other effects. So we have to account for this. And this obviously puts us in the space where sometimes, we hear this often. You may have said it, you may have experienced it. Where somebody says, our business is prioritizing, new requirements over technical work. What do they think new requirements are made of? Pixie dust? Their new requirements are made of technical stuff. All requirements work is technical work. There is no such thing as we're not allowed to do technical work because we're working on the requirements, unless your requirements live on a whiteboard and never actually have to be deployed. At that point, yes, I concede. You can prioritize requirements, just not actually getting them into the world. Getting them into the world is a process that has consequences. The problem is we've ended up misusing the term maintenance. We've ended up using the term maintenance to mean fixing bugs. Well, that's just dealing with defects that were always there. That's not through wear and tear. That's not the advance of time. It's broken, and it always was. From the moment that bug was there until you discovered it, 6 months' time, 1 year's time, it was always there. That's not maintaining it. That's actually fixing it in a deeper sense. So we've kind of, and the other people, you see this again with project thinking. We have a lot of project thinking in software, which is unfortunate because software is mostly not done in projects. It's products. You see there's a real bias here. We even hear a project is a thing that has well-defined end state and you're done. You know, sort of speak to developers and say, yeah, this project has been going for 6 or 7 years. And it's just like, wow, that's as long as it took to put humans on the moon, pretty much. Your project must be really late or really complex. It's like, no, that's because it's not a project, it's a product. In software, we've misused the term to the point, I still find myself referring to projects. It's deep in my vocabulary, deep in my vocal habits. It is also in our environments. Open up an IDE, you're offered the opportunity to create a new project. That's bullshit. Because if it were a new project, when do you think you're going to be done with this? Yeah, that would be a useful thing to have, but I'm not going to suggest that. The point there is that that way of thinking about it is deeply flawed. So the idea that we have with maintenance is that we've ended up with project thinking, and then we've done the initial release, and then it goes into maintenance, which is actually, dwarfs the original timeline of the project, so-called. And what is maintenance? It's either bug fixing or it's a thing we call software development. It's where we add new features. Yeah, we already have a term for that. Okay, so I'd like to reclaim. I suspect I'm not going to be able to reclaim the word maintenance here. So, I do have a lot of what we want to talk about here is actually about identifying and naming concepts. And I have a copy of the Oxford English Dictionary on my laptop. It's one of the few things that I actually install that doesn't just kind of like come from the internet every time I get a new laptop. It's just, now I've got physical optical drives, or physical optical disc. We only have one optical drive in the house. Every few years I have to hunt, where is it? And I install a number of dictionaries, because I think dictionaries are fun. I even have like real-world paper kind of dictionaries. I think dictionaries are fascinating. The OED is particularly fascinating because it is almost entirely useless as a usage dictionary. If you want to find out the meaning of a word, this dictionary is useless because it's an etymological dictionary. It starts with the original meaning of the word and works forward. The meaning you want is probably at the bottom. You don't actually want to find out how it was used 800 years ago. That's not how we use it anymore, unless you want to find out how it was used 800 years ago. Yeah, it's good for word nerds. However, it does give some fairly thorough definitions. So let's talk about this idea that we are dealing with, which is that we frame and understand the world of software, the world of insubstantial things, through metaphors. A metaphor is not just something that is poetic, it's actually something deeper. We're going to see that it's deeper. Figure of speech in which a name or descriptive term is transferred to some object different from, but analogous to, that to which it is properly applicable. And the key word here is transfer. It literally means that in ancient Greek. It is the idea of transfer. We are going to try and say, well, you see this thing that's really kind of complex and difficult to understand, or that is novel, or is abstract. What I'm going to do is I'm going to create a mapping. I'm going to say, you know this thing? Yes. You understand this thing? Yes. I'm going to say, by understanding this thing, I'm going to give you points of correspondence so you can understand this thing that you don't understand. Awesome. So that is the basic idea of a metaphor. Why does it matter to us? Well, in a book I co-authored a number of years ago, actually the genesis of that book was in this building, bizarrely enough. We talked about a number of things on patterns, but this particular book was a more philosophical book. And we ended up talking about the nature of software. The aphysical and invisible domain of software is more about metaphor than matter. We end up dealing with every one of our names. Sometimes we overuse a metaphor. Too many managers in your code base. You might have too many managers in your company as well. But that's the point, is that a manager is a metaphor. We sort of say, well, if I understand the thing in the real world, then I understand here. So if you have everything as managers, then you should already know that's not a good thing, okay? It's kind of clear from the name. I'm not saying you don't want managers, it's just that when most of your code is managers and anemic domain objects, that's a bit of a problem. But the idea is we are using concepts from the real world to describe things. The very basis of everything that you do. If I use the word network, that's a metaphor. If I talk about Windows, that's a metaphor. None of it's real, kickable stuff, but we're describing it in terms of real, kickable stuff. So that's what you're ultimately dealing with. And then we might, abstract a bit further. We might rise to the dizzy heights of assembler, but normally we don't work at that level. We kind of do stuff like this. Okay, so this is some Erlang. And we add concepts to it that are simply not present at all in the underlying ones and zeros. We regard indentation as significant because we are visual creatures. Okay? We use separation to apply significance and group things. Say, I want you, the reader. This is for you. This is not for the hardware. The hardware doesn't sit there going, whoa, that's badly aligned code. I'm not running that. I mean, I think it would be fascinating if we did have such an opinionated style of hardware. But none of this has any bearing on what's going down at the lower level at all. It's so disconnected. It's a formal domain. We have other ways of visualizing structure. We have even conventions for how we talk about this stuff. And when you draw layering, do you draw layers from left to right or top to bottom, or just kind of randomly across the whiteboard? Well, no, kind of top to bottom. We even give a sense of gravity to our software. It has an up and a down. We use our physical frame, our physical framework to try and understand this abstract thing, and we give it names. We can talk about it structurally, we can talk about it temporally, we can talk about it in terms of states and time and transitions, and we have a rich vocabulary here. We borrow words from the real world. We say, this is this. And it's just like, oh, there you go, this is the bit where you get hungry. Stack of pancakes, yummy. The point there is that all of this is how we reason about the stuff down there, but it also applies to our processes and the activities we have around things. This kind of interest in metaphors goes back, I mean, look at that cover. I mean, that's a beautiful, I mean, it was published in 1980. You've got that kind of like just at the end of the 70s vibe. Nobody would would have a book cover like this anymore. And Lakoff and Johnson, Metaphors We Live By, they really explored in depth how we as human beings use metaphors deeply within our language. It's not just a matter of poetry. The essence of metaphor is understanding and experiencing one kind of thing in terms of another. Okay, that's all good. So let's evaluate what it takes for something to be a good metaphor. Occasionally people will sort of say things like, oh, that metaphor's not perfect. We'll say, okay, let's talk about software architecture. Yeah, the architecture metaphor's not perfect, and they will use that as if that's a bad thing. I'm like, well, no, there's no such thing as a perfect metaphor. Because if it were a perfect metaphor, it wouldn't be a metaphor. It would be the thing. So by definition, a metaphor is an imperfect mapping. And that's fine. But we can grade them as to whether or not they're better or worse. So I wrote this piece for O'Reilly Radar a couple of years back, because honestly, what the hell were we doing a couple of years back? Sitting at home, staring at each other on screens. So I might as well write some words. And so I talked about technical debt, and I evaluated what I felt, what are the three kind of key ideas that make a metaphor good. Not good in an absolute sense, we're going to see it's context sensitive. To be considered good, a metaphor has to offer a number of points of useful correspondence with what is being described. If it has loads of, if it doesn't offer these points of correspondence, then it's, well, yeah, it's not helpful, okay? So that's the primary one we normally look at. Because what I want to say, you understand this feature, this set of concepts or words, these can be found over here in the thing we're trying to describe. Great. Another quality is that it should not have too many obvious points of conflict. That's the tricky one, because there will be conflict. But that's not a choice. You will have differences between the metaphor and the thing you're trying to describe. That's fine. But they should not be egregious and awkward. You should not spend your whole time apologizing for the metaphor, okay, and working around. I mean, I know as software developers, we're very good at working around things, but you don't want to work around your metaphors too much. And then this one, which is the really context-sensitive one. Third quality of a metaphor that makes it effective is familiarity to its audience. And this is really important because you might have the best metaphor in your head, and then you offer it to other people, and they have no idea what you're talking about, because what you're trying to do is you're trying to explain something in terms, well, basically, let's put it this way. Here's a thing you don't understand, and I'm going to explain it in terms of this. If you don't understand this either, then I have to explain the thing that I was going to help you understand. No, this gets messy. Too many levels of indirection. Okay, so let's actually have this is a good one. This is a thought from Chris Matz. It was written up by Steve Freeman a number of years ago. You can find Steve's blog piece on this by using the Wayback Machine. So, but the observation, bad code isn't technical debt, it's an unhedged call option. Okay, who here knows what an unhedged call option is? Okay, so a few of you do. For you, I'll take the observation here. For people in fintech, this is a really interesting analogy. For people outside it, it is not only, I think it qualifies as almost entirely useless. Here, this thing that you understand, or this thing that you have some understanding of, I'm going to explain it in terms of something you have no idea of. And I can explain the derivatives market, which is a glorious work of fiction that apparently is worth quadrillions of dollars, which is actually more than if you converted Earth into its basic materials, pretty much. It's just like, no, this is a daft idea. It's betting on a bet. But that's just me talking about fintech. But the point is, if you are in this space, then you might go, oh, yeah, I see that. That works. Light bulb moment. But if you're outside it, so therefore, the goodness of a metaphor will depend to some degree on the audience. Now, often we favor metaphors that can be shared broadly. Okay? Even if we don't understand them perfectly. I mentioned software architecture earlier on. I think everybody thinks they know what an architect does, and what they actually do is quite fascinatingly different to what we think they do. And they understand building architecture. Why? Because we live in buildings. So therefore we understand them, right? Yeah. My wife used to be a primary school teacher, and she said one of the biggest problems that she had was parents who knew about schools. Why? Because they had been to one. It turns out that when you are 6 years old, your experience and knowledge of a school is quite different to when you are 36. Okay? It turns out that knowledge is not transferable across 30 years. It doesn't have the same meaning. No, you have no idea. So we often have a very naive understanding. But we do try and work with metaphors that have broad appeal. When people talk about software and engineering, they normally appeal to civil engineering for the same thing. We understand what bridges are and so on. People often don't talk about chemical process engineering because only chemical process engineers would know what they do. But it turns out software probably has more points of correspondence with chemical process engineering than civil engineering. So we have this notion of this mapping. So let's go back to the dictionary. Let's look at this other word that I've been using, legacy. So legacy is interesting. Legacy is interesting because it normally has a positive meaning in English. We normally use the term legacy favorably and positively. Someone's legacy. We only describe legacy as a bad thing by adding another word to it. By default, legacy means good. If we say, a bad legacy or a poor legacy, then we've qualified it as negative. But on its own, it has a default positive meaning. In software, we have taken a good idea and, messed it up. But we only did this, it depends. So 1989. For some of you, this is before you were born, and you're thinking, well, that's obviously an ancient concept and timeless because it existed before I existed, so therefore it is old. For those of us who were around in 1989, we might be surprised at how young this vocabulary was. What did people call it before then? Did they just express frustration without words? And we have a definition, which is it's not bad. It's kind of adequate. Designating software or hardware which, although outdated or limiting, is an integral part of a computer system and difficult to replace. So actually, that's not a bad definition. But legacy does not have one unique defined meaning. I actually run workshops on this, as I said, and a part of my software architecture courses, I do often run a section where I ask people, what do you mean by this? Because often we will find different people mean, I'm working on a legacy system, has a different meaning in different parts of the organization. And sometimes for some developers, legacy code is, code that I didn't write. At other times, it describes something that is it's a money sink. It's costly and difficult. At other times, we're actually describing something that is outdated. And actually, there's a problem there of lack of knowledge. The knowledge of what makes the system legacy is the knowledge walked out of the door years ago. We don't have anybody here who's still working on it. We define legacy as the absence of knowledge and capability. In other cases, we're dealing with, well, yes, we still have systems running on Windows XP, even though Windows XP was retired formally 10 years ago. And we're describing those things, and we're describing the difficulty getting people working on it. So there's lots of different ways we approach the term legacy. And I'd like to look at it in terms of other consequences. So this was a post I saw a few weeks back. Angel Ciandona described legacy code as often defined as code that makes more design decisions than the team working on it. I thought that's a really good way of looking at it. I think that's a really, it's just like, So, right, we're going to have a design meeting. Who's turning up? Well, there's me, there's a couple of senior developers, we've got 4 or 5 junior developers, and we've got the code base. Hi, code base. Did you get a coffee for yourself? You good? Okay. And it turns out, there's the rest of us making decisions, and the code base is sitting there going, nope. Nope, we're not going to do that. Oh, no, that's not something you can do with me, I'm afraid. I have a veto on this. Oh, you want to be agile? Have you seen me? No, it's just like, it's not going to happen. The code base actually has the casting vote. The code base is making the decisions, and everybody else is like a puppet. Okay? And actually, Angel goes on to say, could we define a legacy process as one that makes more decisions on how a team functions than the team itself? That's about the culture and the tools, but also shaped by the very software that we're dealing with. So that's kind of an interesting way of thinking about it. But we are certainly seeing, what we're learning is whichever way we look at it, legacy tells you how you're going to spend your time. In fact, that's one of the definitions of architecture that I tend to favor, is that your software architecture tells you where you're going to spend your time. And that may be a good thing or a bad thing. Yeah? But it tells you where you're going to spend your time. So I stumbled across this article. I think it was published last year. Over $1 trillion to keep the lights on. Legacies drag on productivity. Whew, this is big numbers. Okay. 2019, US Government Accountability Office report found that the federal government spends more than $100 billion on IT and cyber-related investments annually. Okay, big numbers. Of this amount, agencies have typically spent about 80% on the ops and maintenance of existing IT investments, including legacy systems. That's a pretty hefty amount, pretty hefty proportion of existing stuff, not new stuff, existing stuff. So let's look more broadly. So on average, if we move outside the US government, on average, 31% of an organization's technology is made up of legacy systems. And you might initially think, oh, that's not too bad, that's less than a third. Just remember that 2/3 is waiting in the wings to become that, move into that. But remember, quantity by proportion is not everything. It's not the 31% that you have to worry about, it's how much are we spending on that 31%. Oh, that's quite different. Maintaining those systems, that's a disproportionate amount. Maintaining those systems can be a costly burden with an average of 60 to 80% of IT budgets allocated to keep them running. Woof, that is, okay, that's kind of different. Of course, we focus on new stuff, and you find most of the sessions that you may have been to focus on the new stuff. Legacy technologies hamper efficiencies and restrict growth in an estimated 88% of businesses. I don't even care if this estimate is, 88% is two significant figures. That feels surprisingly, I'm not quite sure you can quote it to that based on the variety of the industry. But honestly, even if it's 50% wrong, it's still a massive amount. It's just like, wow. Legacy is a constant drag force on development. So in this splendidly titled paper by Adam Thornhill, Marcus Borg, and Ernest Mearns, in fact, Adam Thornhill, he's done some really good work. A lot of code analytics stuff. Has anyone come across the book, Your Code as a Crime Scene? Yeah, so he's done that. Second edition's out in print. I am biased, I wrote the foreword, but the reason I wrote the foreword is because I think that the book is so good. The whole idea of if you want to answer half the questions that you have of your system, go and ask the system. Yeah? Invite it to the meeting. It turns out it has a lot of history. That is one of the good things about a legacy system, is it has history. The thing we're not very good at is learning from history. You can actually go and find out from the code base, what are our hotspots of change? What are the areas of avoidance? What are the parts that people touch and who owns what? what things get changed together. There's a lot we can actually ask. What are the trends in the code base? Look at the trends. But they thought, right, okay, let's find out a bit more. AI, it's a thing. Refactoring versus refactoring. Advancing the state of AI automated code improvements. We might think, okay, legacy, we have a way out. We are going to use AI. Sprinkle pixie dust. We introduce a novel innovation. This is one of the interesting things. So I'm actually putting one of the conclusions here first. We introduce a novel innovation for fact-checking the AI output and augmenting the proposed refactorings with a confidence level. By rejecting incorrect solutions, 98% of the remaining AI-generated refactorings improve the code while retaining the original behavior. Now, what is important to understand here is what they're saying is the raw output from an LLM is not sufficient. You need to do fact-checking just like you do with anything else. Every time I've asked ChatGPT anything, it's just like, yeah, but I happen to know the facts on this one, and that's kind of a little bit wrong there. But you're delivering it with kind of like sociopathic confidence. You need to approach these things with a bit of skepticism. And the point here is that what they've done is they've added fact-checking. What happens when you don't have the fact-checking? So, by definition, a refactoring is something that doesn't break something. Yeah? Hey, I've just done this awesome refactoring. The code doesn't compile. Small detail. It's so awesome. What happens if you just leave, if you use an out-of-the-box LLM, hit or miss situation? Oh, how hit or miss? In fact, the best performing model only giving a 37% probability of success. That's absolutely shockingly bad. I mean, if your success rate with refactoring was this low, it's just like, wow, that's pretty bad. If a developer had this success rate, you would really kind of go and have a little conversation with them. Say, is everything okay? I mean, are you good? I mean, do you need some time off? Maybe a different industry, like not software? That's a really bad number. So out of the box, this is not good stuff. So no, the path is not going to be given to us by this. And we'll also see some other interesting consequences of this. Because we also have to go back to the fact that the boat is taking on water. Okay? Part of the thing is not fixing the stuff that comes out, is actually the creation of legacy code. So this is the bit where I predicted the future, but it turned out to arrive a little bit sooner. This was April last year. So I posted this on Mastodon. Practical consequence of using LLMs to generate code is that many developers will find they've unwittingly moved themselves into a role they were probably trying to avoid. They have automated the creation of legacy code because who wrote it? Well, somebody else. It wasn't me. But yeah, I took the fun bit of my job and now I'm left with shit because I have to fix it and understand it. I've actually made my job worse. They've redefined their job as debugging and fixing such code. Now, I'm not saying this is all bad. What I'm saying is that this is like any tool situation. What we have learned is that a lot of people put, oh, here's a people problem. Let's solve it with technology or tools. And it's just like, no. I actually did a talk, NDC London last year, where I was talking about refactoring and the fact that, I sometimes joke, here in the 2020s, I think it's so great that nobody has to deal with, long methods that have their own kind of event horizons. That people don't have to deal with incoherent, messy classes and like dependencies that, just have just this tangle to them that you will never disentangle. I think it's great that people don't have to look at code that is meaningless and ugly and difficult to change. Because you know what? You know what happened 20 years ago? About 20 years ago is when automated refactoring started becoming normal. We solved the problem 20 years ago. 90% of the problems people experience on a daily basis were solved over 2 decades ago. And then you kind of think, oh, right, so it wasn't the tool, was it? We've got the tools. It's to do with our skills and our environment, our situation. Turns out it wasn't a tool problem. Turns out it's not a tool problem. So here's where I got proven kind of right. Somebody sent me an email just the beginning of this week. Oh, Kevlin, here's the study, coding on Copilot. And this was done Well, obviously I'm going to say that there needs to be more follow-up research on this, but the folks at GitClear had a look. 2023 data shows downward pressure on code quality already. I mean, if Copilot were a human child, it wouldn't have even gone to school. In fact, it would probably be toddling around, asking for another biscuit or something, with barely a grasp of language and barely an understanding of gravity. 150 million lines of analyzed code. Projections for 2004, not good. This is the current trend in terms of code churn. So we find disconcerting trends for maintainability already. This is the bit that gets me. I was kind of thinking, oh yeah, I'll be talking about this in the late 2020s. No, it's already happened. It's like code churn. The percentage, so they had a definition, the percentage of lines that are reverted or updated less than 2 weeks after being authored is projected to double in 2024 compared to 2021, pre-AI baseline. That's pretty bad. So what's interesting here, they went further. We further find the percentage of added code, copy and pasted code, is increasing in proportion to updated, deleted, and moved code. There's all these people who keep joking about, well, you shouldn't use copy and paste. It's just like, no, let me use AI instead, because it's copy and paste via an indirect route. Yeah? But actually, that's the problem, is what's happening is people aren't perceiving their structure. They're solving a problem in the situation because that's where they're focused. I'm not going to blame people for being people because you're focused on it. But the problem is, unless you know that this comes with a tool. You see, this kind of tool is going to have a huge impact for people who know how to use it. Just as refactoring tools, when you see somebody who really understands the concept of refactoring and the tooling they have, when you see them work, you go, oh, okay, there's a real difference between what you're doing with that tool and what the majority of people are doing with that tool. And I think that's the same case here. The people who know how to use this and understand its limits, but also understand how to get its advantages, are going to be way ahead of the rest of us who are going to be busy slowing down. In this regard, code generated during 2023 more resembles an itinerant contributor, prone to violate the dryness, don't repeat yourself, of the repos visited. So, itinerant contributor, the point that they were making, in fact, the question they were trying to answer is, if we use an AI assist, do we end up with code that tends towards the skills of a senior developer who belongs to that organization and has experience and history and a vested interest in that organization? Or do we end up with code that reflects perhaps the style of a short-term contractor? We have the answer. It reflects the style of a short-term contractor. It's like, again, I'm not going to, short-term contractors, no problem with that. It's just you need to understand what you're getting and what the incentives are. It's not even just a matter of skill. Sometimes we can have our skill nudged in the wrong way by the wrong incentive model. But here we've automated that problem. We've made it potentially worse. So no, this is not the way out. The way out is, first of all, we need to start rethinking about this. So let's go back to the kind of territory of metaphors. Legacy code. That's one way we try and talk about it. We also talk about things in terms of spaghetti code, a term from the 1960s and 1970s, which is referring to control flow. It's not really a metaphor because I mean, I like spaghetti. It's just, it is my favorite pasta. And it's just like, you're describing this code in those terms. You're trying to draw a visual parallel, but it's not truly a metaphor in that sense. I'm not using it as a means of understanding. And then people try and then switch. There's a kind of odd code switch they do to the metaphor of lasagna. Oh, you don't want spaghetti, you want lasagna because it's layered. It's like, actually, I prefer spaghetti to lasagna. Lasagna's not necessarily good or better, and then what I love is that each generation rediscovers the meaning of ravioli. When I first heard that in the 1990s, somebody said, oh, you want ravioli code, object orientation. And then as the 90s wore on, it became components, and then it became services. And these days it's microservices, which bizarrely are larger than services. This word micro, I don't think it means what you think it means, okay? But the point there is each generation, each hype cycle, somebody rediscovers these things. But it's not really a metaphor. And I don't think it's a very helpful way of describing things. Then we move into stuff that starts describing physical processes, code rot, software decay. Now, these are quite nice because built into them, These move us in the right direction because built into them, there's a concept of time. There is a progression of time and a degradation over time. Yes, that's what we're talking about. The only problem with these really is that they require a kind of natural process. And that's not really happening in software. You know, if you leave that yogurt in the fridge for a few months, we can rightfully call it an experiment in biology. You didn't have to do anything. It just became that way. Okay? There are natural processes working on it that are separate from you, which is not really what's going on with the code. Sometimes you can get a situation where it's almost a relief to find that nobody's changed a file in 5 years, because at least you know it won't have got any worse. You know, if you happen to know, oh yeah, there was a big merger 4 years ago and everything went to shit, you can at least say, well, you know, 5 years, this code hasn't been changed in 5 years, then, you know, that's probably better than some of the other things that are going on. We have stasis by default. So these are getting towards a good metaphor, but that notion of natural agency doesn't quite get there. But it does suggest maintenance. Entropy, I always liked entropy as a way of describing it. Company I worked at, first company after university, we used the term entropy. Technical debt hadn't been invented as a term at that point. We used the term entropy, or a number of us used the term entropy, and that's because we all had degrees in physics. And for us, this is like, yeah, this makes a lot of sense. The problem is that it turns out that that's not necessarily common knowledge, and you end up with the explanation of, let me explain the second law of thermodynamics. Your audience, their eyes have glazed over. You're trying to explain a thing that's hard in terms of another thing they don't understand. It's just like, no, this is not going to work out well. Technical debt, the one that we are familiar with. Unhedged call option, one that may make more sense to the fintech crowd than, say, the physics crowd. Well, actually, there's a bit of an overlap there. Housework, I love this one. We'll come back to this one in a minute. So, the popularity of this term. Technical debt is a wonderful metaphor developed by Ward Cunningham. This is Martin Fowler writing in the early 2000s. Unfortunately, he's since updated this blog post. I wish he kind of kept it, because historically it's quite an important. Of course, you can use the web archive to go and find the original. Because for me, it's quite a historically important one, because it helped popularize the concept. After 2003, the term became much more popular. So Ward Cunningham, if you're not sure who Ward Cunningham is, he's the guy who invented the wiki. He also came up with Cunningham's law. If you don't know what Cunningham's law is, you do know what Cunningham's law is, you just probably didn't have a name for it. It is the observation that if you want to get the correct answer on the internet, post the wrong answer. Yeah, if you just ask a question, it won't get answered, but if you post the wrong answer, boy, people are happy to correct you. In this metaphor, doing things the quick and dirty way sets us up with a technical debt, which is similar to a financial debt. Notice he's saying which is similar. It's a metaphor. It's not the same. But we do have a slight problem, is that, and I'm not going to blame Martin for this solely, he uses the term quick and dirty here, which has negative connotations. It's a US English term, okay? And basically, it suggests expediency, but it suggests, you know, a kind of like, yeah, it's a bit of a screw up. You know, it's kind of, yeah, it's not perfect. It's a hack, it's a workaround, it's a kludge, it's a whatever. It's got a certain badness, if you like, built into the term. The problem is that we pick up on these things, and most people's experience of debt is inherently negative. The debt crisis and things like that. So yeah, we have all of that. So it's worth looking at what Ward actually wrote back in 1992. What is interesting is that he introduced the debt. He did not use the term technical debt. In the 1990s, people variously used different terms. Technical debt, design debt, quality debt. I generally preferred design and quality debt when I talked about stuff. Technical debt kind of became sealed as the term in the 2000s, and particularly as it took off and became a standard piece of vocabulary in our kind of discussion of software architecture. But what Ward says may surprise some people. Shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with a rewrite. What he's talking about here is a considered trade-off. He's talking about, in fact, really it's not a debt metaphor. If we look at it very carefully, it's a borrowing metaphor. I need to do a thing now, but we don't have the time or the knowledge. And sometimes we just, okay, this is a new piece of the tech stack. How do we do the perfect job? We don't know yet. But, well, I'll tell you what, let's just try this and see what happens, and then we kind of come back with our knowledge. We do that, and we know that it's not the perfect way. It's the one that looks like the examples in the blogs. It's a bit copy and paste. It's a bit kind of put together. It's a bit based on our previous preconceptions of how we've worked with other frameworks or pieces of code that are like that. And we know that it's not going to be perfect, and that's fine. That's great. Sometimes we're doing this because of reasons of time, that to do the full job is going to take a lot longer, but we'd like to have something out in the field, and then we'll see what the feedback is as to whether or not we spend more time. The whole idea is that it's a considered trade-off between 2 points of time. I don't have the money this month, but there's a thing that will be only available this month. Therefore, I will use money from next month. Notice the borrowing metaphor. The money from next month. Well, I know where it comes from. To do something now. That was the whole point. Ward had a positive view of this. He was using debt in its kind of, more formal sense, the way an economist might look at it favorably. The danger occurs when the debt is not repaid. In other words, that wasn't the point. He's just saying, oh, by the way, there's bad stuff as well. Of course you were not going to do this. Of course you wouldn't. God, wow. Every minute spent on not quite right code counts as interest on that debt. Hence, the basis of the metaphor, the idea of the interest, the extra work you have to do on it, the fact that people are going to start working around it, the fact that that's going to become your architecture if you're not careful. Yeah? Oh, yeah, this was just a workaround. 2 years later, this is our architecture. Yeah? So that observation. Although we know by definition no metaphor is perfect, there are two common ways in which the metaphor is misapplied. One is assuming that it's necessarily bad. Not all debt is necessarily bad. Okay, sometimes it can be a bit of a drag, but on the other hand, if you've got a mortgage, which I always love the fact that the word mortgage contains the word death in it. There's kind of a clue there as to what it's going to feel like. But it's an intentional trade-off. It's structured. It's a structured repayment. You have some control over it. What are you getting in return? You're getting a house. Oh, okay, that's not a bad deal. Fair enough, because you can't afford a house otherwise, unless you're extremely fortunate. But the idea is like, yeah, I can't afford a house today, but over a period of decades, I can cumulatively afford a house. So therefore, I'm able to achieve a benefit I otherwise would not have. This is the positive idea here. Okay? And we have a management model for it. We have a repayment model. That's what most people are missing, is that they're not using the borrowing metaphor. They're using the kind of like, yeah, we're just running up a debt and crossing our fingers kind of approach. Whereas it's actually borrowing. You're borrowing from your future time, your future opportunities. That's where that kind of 60 to 80% of the drag on opportunities is coming from. Or the 88% drag, sorry, the 60 to 80% of cost. Equating technical debt with a financial debt value. This is a mistake. And sometimes people push the point of them. At this point, it's not a case of, it's not a case that the metaphor, we have to recognize the metaphor is intentionally incomplete and imperfect. Unifying it with financial debt is an incredibly bad idea because it gives you a kind of a false sense of reality, and it's based on incredibly bad science. There are also tools that will automate this bad science for you. They will look at your code and they will say, this is how much technical debt you have in your code base in pounds, euros, dollars, etc. And the technical term for this technique is bullshit. I mean, if you need me to break that down for you, this is bad science on a staggering scale. Please never, I've had people sort of, yeah, but we use that number that's generated by product that I'm not going to mention now. We use that number because it allows us to talk to management. And I said, yes, but I said, this now becomes a moral question. You know it's bullshit, that means you know you're lying. Yeah? I leave that to you as to what you want to do with that fact. But the problem is, why is this bullshit? If I've got a piece of duplicated code, and we generally agree that going around copying and pasting everything is not generally a good idea. But can I look at one piece of copy and pasted code and say, the cost of this across the whole code base is this amount? Because it turns out that, well, no, you can't, because you need to know context. Sometimes there are little parts where duplication will benefit, and it will allow you decoupling. So I cannot say that there's a constant cost per 1,000 copied lines that you will incur. You can't do that because you'll actually go, oh yes, this apparent duplication decouples these two systems, and that saved us a lot of time. Yeah? Had this situation with a company a few years ago where they had accidentally tried to do a reuse program, although they intentionally tried to do it, and the reasons people do this is because they want to achieve a benefit, typically in time and quality. What they discovered is that they ended up coupling two otherwise independent teams together, and they slowed them both down, rather than... And it was a case of like, right, how much logic is actually duplicated? 5%. You know, that's a fair cost. Yeah, pay your 5% duplication, and the minute they did, it's like, oh, we're all back on schedule. So the point there is you cannot do this with the code base in any sense that's automated. So again, we return to this thing about the effect and understanding the cause. And the notion of technical debt, that what's really going on when people are talking about technical debt primarily is unmanaged technical debt. There's a word missing. People say, oh, we have a technical debt problem. Perhaps they do. But not in that phrase. It's an unmanaged technical debt. The minute we put the word unmanaged there, it invites the question of why are we not managing it? Because it's the managed stuff. You know, if a team said, oh yeah, we've got a whole load of technical debt, you know, and this is how we deal with it. We put stuff in Jira, we write ADRs, we devote a certain portion of every sprint to dealing with it, and all the rest of it. It's just like, well, you don't have a technical debt problem. You're managing it perfectly well. You've got a sensible repayment model. That's not a problem. You might have a lot of technical debt, but you seem to be doing the right things with it. The problem that we have is the unmanaged stuff. Where does it come from and where does it go? I feel like Cotton Eye Joe, but no. So, the Cotton Eye Joe paradigm. So the point here is that's the real problem. The unmanaged stuff. How did it come to be and what are we going to do with it? Yeah, this is the hole in the boat. Okay, we need to address the fact there is water and that we are taking on water. That's the question we need to be asking. Martin Fowler also had a way of looking at this called the technical debt quadrant. He uses slightly different language. He talks about reckless versus prudent debt and intentional, deliberate debt and accidental debt. I tend to use slightly different words because these ones help you focus. If I say unmanaged, this immediately implies there's a managed. And the question is, okay, and I'm also not making a moral judgment here, whereas when you use the term reckless, there's a strong moral judgment in that phrase. So for me, I'm interested in this. And what are the consequences of this? Well, what do we have? If you do this, you will have staff retention problems. You'll have potential security problems. Because if you're saying we have unmanaged technical debt, you're basically saying, who knows what our code is like? We don't have full knowledge of it or full control of it. Oh, by the way, yes, we do believe in security. Well, no, you just told me you didn't. You can't both believe in security and say, honestly, we have no idea what's going on in our code base. Security is a kind of like a multivariable thing, and being able to control your code base and your dependencies is part of that story. If you don't know what's going on there, then you are vulnerable. And if you say, oh yeah, our code base is totally vulnerable, but we're secure, those two phrases don't inhabit the same universe. Compliance, defects, everything just becomes harder. So that's the message of the technical debt metaphor. It's not simply a measure of the specific work needed to repay the debt. It's the additional time and effort added to the past, present, and future, if we don't address it, that comes from having the debt in the first place. If you want to go back to fintech, this is a complex financial instrument, and we don't know the future. The idea is that it's about how we respond to it. And if we're going to talk about response, then here's Yvonne Lamb's observation. My theory of tech debt is that housework is the correct metaphor for the thing we call tech debt. But we can't use it because tech's been made up of people who don't do housework or manage housework being done. Spot on. Well done. Remember, it's to do with familiarity. Yeah? Is it familiar to the audience? Yeah? And I'm going to say that for a lot of people, housework, that's what Douglas Adams called an SEP. Somebody else's problem. So, speaking of housework, this is Isabella Beaton. She, Victorian figure, she died when she was only about 30. She was a contemporary of people like, if I remember correctly, if I've got my timelines right, contemporary of Ada Lovelace and Charles Babbage. But she gave us the best wisdom on software development without caring about calculating engines of any kind. She wrote a book on household management that has actually survived into the 20th century. And she gave us the advice. Let's go back to the mess I'm making in the kitchen. There is no work like early work. Clear as you go, muddle makes more muddle. Wow. It's just like the wisdom, software development wisdom encoded in a book of household management. Very clever. That's cryptography for you. Not to wash plates and dishes soon after using makes more work. The advice is there. This is what modern commercial kitchens run by. It is the very simple observation that, we're going to talk about the debt. We're going to talk about debt and interest. The amount of effort with respect to time, if you do nothing else, it rises exponentially. And because that means you are doing, or you're having to work around or deal with all the stuff that you have accumulated so far. We can go for a punctuated approach. Okay, a punctuated approach is very much, okay, we'll devote a certain amount of time and a certain number of people at particular points in time to kind of let's go through and just have a bit of a discussion, a bit of a meeting. Let's go and find out what's the dead code, what are the areas of high code churn we should be worried about. Do we have any ADRs that look like they need revisiting? Do we have any other comments and things in Jira that we need to... Let's actually do this and have a kind of like a regular kind of cleanup. And that kind of drops this, it amortizes it. And then, because everything is continuous these days, we recognize continuous everything implies, well, do it clear as you go. The idea is that there's not a separate piece of time that you're going to allocate to this. Because I'm going to recognize that maintenance is, in this sense, ongoing. One of the things about software is that it is not physical. It is a thing that we can do at any point in time. Doesn't have logistical barriers the way that many things in the real world do. So we are in a position where, if that's part of our workflow, we don't mark it out as separate. So, let's close with this thought that maintenance is an action. But what we're really worried about is inaction. It's the problem, it's the absence of something. It's a very, very interesting model. John Seddon, who's not a software guy, he's a systems guy, broke this down very nicely. Demand, so economic terms here, supply and demand. What is the demand for my work? If I am sitting here at the keyboard, why? What is the thing that I am doing? What causes me to do this? Am I adding a feature that somebody has requested and will be of benefit to them? Value demand represents the demands customers make for the things they want, things that are of value to them. Or am I dealing with failure demand? Failure demand is created by the organization not working properly. More specifically, failure demand is demand caused by a failure to do something or do something right. How much of our work comes from something not being right or not being done right? There's always going to be some amount. By the way, we're not aiming for zero, we're just aiming for less. Obviously, fixing a bug is an example of failure demand, but so is sitting in front of something going, I have no idea what this does. And the last person who did left 5 years ago. Yeah? That is, coming up with ingenious ways to work around things. Yeah? This is failure demand. And if we're talking about the thing about, inaction, then that's the word neglect. Want of attention to what ought to be done. The fact of leaving something undone or unattended to. Negligence. If we look at actually how much, this is quoted in Adam and colleagues' paper, from another paper published by the IEEE, if I remember correctly. There you can find various different versions of this lying around. How much of a developer's time is spent on actually writing and editing code? Notice where our tools are targeted. That little 5% there. Yeah? Don't lose that 5%, it's fun. Understanding. So it turns out, I did this estimate utterly informally, there's no science behind this, at one organization a few years ago. I estimated that I remember saying to the department head, I said, in an 8-hour day, your developers are lucky if they're actually spending an hour dealing with the future. They're spending 7 hours fighting the past. And that's on a good day. Okay? Most of the time, they are dealing with the consequences of exactly that, neglect. We have let something go, and now we have a problem with it, but we don't have the language or the framework the way to approach it. So let's end on that thought, that a lot of these things are about increasing our awareness. It's to see the thing that we're not seeing, to notice the absence in our habits or our culture for supporting something, to understand what the tools do and do not give us, and how we can integrate that into a flow. So you literally don't have to think about it. That's the point. Habits are things you don't have to think about. We want to integrate this, to recognize that all those little actions can accumulate to something better. When we look at the overall cost of negligence, let's understand that code bases don't become messy, legacy, and all the negative stuff. They don't come that typically through willful actions. It's not anybody being malevolent, going like, okay, today I'm going to go into work and be super evil. Like, this is not some kind of trivial Bond movie, but played out in software architecture. And it's also mostly it's not deliberate. You don't sit around in meetings going like, okay, let's talk about the code we're going to write. Anybody got any suggestions for how we should go about writing it? Oh, no tests. I think we should absolutely abandon tests. That's a great suggestion. And any other suggestions? Yeah, I think our methods should be at least 1,000 lines long, preferably longer. That's an excellent suggestion. Yeah, ha 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 ha. Evil cackle. That's not how it's done. This stuff happens not through any kind of willful action, not through malevolence. It's not even people being stupid or evil or lacking, not even lacking certain skills. Many of us know what the right thing looks like, but sometimes we find ourselves in a situation where we're taken away from focusing on that. But we need to have that bigger view and understand that we're not working on projects, we're working on products. Products last years. That there are consequences. And that your habits start right now. How we spend our days is, of course, how we spend our lives. Thank you very much. Right, so the good news is, by overrunning a few minutes, thank you for your time, by overrunning for a few minutes, I've made sure that you avoid the initial rush for food. How about that? But yeah, if you have any questions, please come up.